So we would today do exercise 1. This is exercise 1A of unit 4. So let me write it is exercise 1A unit 4 math methods. Yeah.
Yeah.
Okay. Have you gone through it or not?
No.
Okay, no worries. We would go through it. So the topic of this is actually logarithmic. So logarithm. Do you have some idea what is logarithm?
I think so. I have a little bit of an idea, but not too much.
Okay, no worries. Can you just say what is a logarithm or why we use logarithm scale?
Is logs to help is it to help with the powers of numbers? Is
Yeah,
it something to do with that?
yeah, that's one thing. But we use logarithmic scales in various measurements. For example, we use it in earthquake measurements. So
Okay.
perhaps you have heard of this thing. It's called Richter scale, RI,
Oh yeah, Richter scale, yeah.
Richter scale for. It's actually a logarithmic scale. Also, perhaps you have heard of sound that is called decibel.
Sorry?
For the sound, the
Decibel.
human sound and other, its scale is decibel, dB.
Yeah.
So these are logarithmic scale. Actually, what the problem is, let me tell you, and then we would. Normally, what you have been learning up till now was a linear scale. Linear scale is, for example, here x, here y, and you are having like 10, 20, 30. You understand? And there y would be something like something,
Yeah.
let's say it's 10, 20, 30 or something similar or 100 whatsoever, but they are
Yeah.
linear scales. The problem is once there is a huge variation, for example in case of earthquake, so you will not be able to plot them. So this is a linear scale which I have just shown, and logarithm brings you a non-linear scale. So logarithmic scale, so let me write logarithmic scale is a non-linear scale, is a non-linear scale.
Mm.
What does it means? Do you understand what is the importance of this? It means you can have a lot variation in a very small region. You can show it
Okay.
in a very small region. We would look at it with few examples first, but let me first give you a background. So let me write it as a background. So we are saying background of logarithm. So let's see that. Let me ask you a few things and we would move. Let's say, do you know what is 10 raised to the power 2?
10 raised to the power of 2 is 100.
Yeah, it's 100. Yeah,
Yeah.
okay. That brings you us to something which is logarithmic. Let me take the color yellow. So it says from here, you can say this is something which is here. So you say log 100 to the base 10 is 2. If you don't
Yeah.
understand, no worries. I would just give few more example and then it would be clear. Yeah. Let's take another example and then I would move towards formula. Let's say, what is 2 raised to the power of 3?
8.
8. Yeah. So it says logarithm of 8 to the base 2 is 3, right?
Hmm.
No worries if you don't understand. As I said, I am just at the moment trying to make a background and few more. And let's say, what is 5 raised to the power of minus 1?
5 versus 0.5.
No, it is 1 over, actually, this is equal to 1 over 5, and
Oh,
this is equal to 0.2, right?
yeah.
Okay, now we move to, in a logarithmic scale, log of 0.2 to the base 5 is equal to -1. Okay, these were just, I gave you few examples, and on the basis of it, we will try to formulate in fact, formula. We will try to formulate a
Mm.
formula. So let's say, so we generalize it. We say, but let me first generalize it, and you try to help me with this. If a raised to the power x is equal to b, so compare it with the three examples which are shown above, right? So in the first
Yeah.
example, what is a? If we put there in the first example,
In the first example, 10.
yeah, good. In the second example,
2.
good. And what is x in the third example?
-1.
Good. So we have this thing, right?
Yeah.
This implies log of b. B is the one which is the result to the
Mm.
base a is equal to x. So this is something. If you compare it with the above, 10 raised to the power 2 is 100. So you can also go from here. So it means we can move from, let me highlight it. We can do like this: a raised to the power of x is equal to b. Do you understand? So we can move from right to left or from left to right.
Yeah.
So you understand that?
I think so. Yeah.
Yes, but there is an observation which I did not write, and that's a condition somehow. So it says for some positive positive a. So we are considering a in all these cases are is a positive thing. For example, here in the logarithmic scale we had 5, 2, and 10 all. So this is something which is logarithm. Do you
Mm.
understand that?
Yeah.
Okay. Now let's see. Let's say, can you help me to find this? Let's say logarithm of log of. So once we write log like this, it means it is to the base 10. Yeah. What
Okay.
is log of 10 equal to? If you look at this this above equation or above definition, what would be log 10 to the base 10?
Um. Would it be 1?
1. Yeah, because 10 raised to the power 1 is 10. Let me ask
Mm.
you one more thing. Log of 100 to the base 10. What you raise this? So look at this. Look at this. A raised to the power x is b. Yeah, I am again highlighting it. So we have now this. So you actually is taking a raised to the power of x and putting it. So what should be here, that you raise 10 to that and you have 100?
Uh. 2.
Yeah. So the answer is 2. Do you get that?
Yeah, I think so. Yeah.
Okay. Let me ask you, what is log 1000 to the base 10?
Uh. 3.
Good. And now we come to the things which we said earlier. If you have a linear scale, if you represent from 10 to 1000,
Mm.
it would be very long. This is 10, 20, 30, and so forth, so on. It would be quite problematic to go till 1000. Yes?
Yeah. Yeah.
But if you see in the logarithmic scale, so I am trying with the red. This whole range is now into 1, 2, and 3 because log 10 is 1, log 2. So the whole thing, if you move to the logarithmic scale, it is compressed. So very high values can be represented by a smaller number. So you got that? Got some
Yeah,
idea?
yeah.
Okay.
I think I get it.
Yeah. So let's do, before we move to the questions, I would do some more questions with you. Um, Let me ask you this thing. Log 32 to the power of, log 32 to the base of 2. So what does it mean? You have to find a number here where I have put this square. What number you raise to that it becomes equal to 32? Have you understood this or no? Again, I am trying
Yeah,
to refer to,
I think so.
yeah,
So that would be 6.
2 raised to the power of 6. Can you count it? 2 raised to the power, if I just write it.
Oh,
Let,
5.
yeah,
Is
5.
it 5?
Yeah, it's 5.
Yeah.
So that's good. So you have understood. Let's ask you another question similar. What is
Yeah.
log of uh, 16 to the base of 4?
So it's 2.
Yeah, it's 2 because 4 raised to the power 2 is. Or let me ask you log of 9 to the base 3.
Would also be 2.
Very nice. Very nice. So we understand that, right?
Yeah.
Yes. Okay. Let me ask you a few things before we move quickly.
Hmm.
Let's do some few examples. What is log of 16 to the base 2?
It's 4.
Yeah, 2, so it is 4. And what is log of 32 to the base 2?
Um, 5.
Yeah, good. It's 5. Yeah. Okay. Let me ask you one more. Maybe I take another color example. What is log 0.1? Actually, we once we put log like this, so you know what is the base?
10.
Yeah, 10. Yeah. So what is this thing?
Would it be -1?
Yeah, very nice. It's -1. Let me ask you log of 0.001.
-3.
-3. And you see something very interesting now again. We saw in the previous examples where we were talking about these thousands and so, or even a million, and they were numbers. And now we have some variation which is very, very low,
Yeah.
0.001. And you are also getting some number which is quite good. So it means logarithmic scale is good to show even very small number and very big number.
Yeah.
And therefore the earthquake actually, it has a very high amplitude. It goes with, so one homework you have is kindly study this Richter scale. Homework for you, just for your Google it and
Okay.
just
Sure.
gather information about the Richter scale. Yeah, you
Yeah.
try to find what is Richter scale. Okay. um, let's do some questions and see how we move forward. um, Can you write what is a logarithmic representation for r raised to the power p is equal to q?
Um.
So what it would be?
Okay. So it would be log uh log base R
Yeah,
Q equals P.
yeah, very nice. Log of q to the base
R.
r is equal to p. Yeah,
Yeah.
that's good.
Yeah.
So that's good. So I think are able to do few things. So we now move to the next part, and then that's the main part, and that is the laws of logarithm. Laws of
Yeah.
okay. There are few laws which you should remember. They can be proved if, but let's see. First of all, we will try to write the laws, and then we would see. So log of multiplication of two numbers, and I just put a here so that it can be to the base any number.
Yeah.
Okay. If there are two numbers, so you can do like this. So logarithm of their logarithm, individual logarithm calculated and added together. Do you understand this?
Yeah.
We do one
Uh,
example,
yes. Okay.
and then we see does it make sense to us or no. Let's say this is log. First of all, we have to find log 100 to the base 10. You know what is that? You
Yeah.
yourself
Two.
told me. We can also write it like this: log of 10 times 10. Can we write it like that?
Yeah.
So it means from above formula, we can write it like logarithm of 10 to the base 10 plus logarithm of 10 to the base 10. Yeah. What
Yeah.
is log 10 to the base 10?
One.
1. And so 1 plus 1 is equal to 2. And that was the same thing which you earlier told me, because that was equal to log of 100 to the base 10 was 2. So even if we have, so with that formula also, we have the same answer. Yes,
Yeah.
sir.
Yeah. I think I get it.
Okay. And you have to note these formula, because I would be giving you some ATAR question in the later part of this session. So
Yeah.
have these formula. Uh, so what I say, uh, first of all, write in your notebook this one, which I am highlighting.
Okay. Yeah.
Yeah, write this,
Give me a
and then
second. I'll do that.
yeah, because I will give you few questions then to solve after these logarithmic formulas. So therefore, you have your so-called cheat sheet ready. Yeah, you have written that.
Yeah.
Okay, let's move to this. So the first law is there, and now I move to the second law. Yeah, that was a times or multiplication. The other is division. So
Mm.
log of. So you should write the first law in the meantime is equal to log of base to the minus log of c to the base a. Do you understand this? The second.
Yeah.
That is something very interesting. If there is a division, by converting into log, it becomes a subtraction. Which is a easier operation, division or a subtraction?
Subtraction.
Yeah. And that is it a what is easy, multiplication or addition?
Addition. Yeah.
That's something also very interesting. So it means going into logarithmic domain, your operation nature also changes. Yeah.
Hmm.
Okay.
Yeah.
Now that's something interesting. It you would if you would do some as in you will go into the university, you would learn that sometimes we go do like this, that we go into other domains and do the calculation, then come back. Let's go to third l- law. Uh, the third law is log of b raised to the power of n to the base a is in fact n log of b. Do you understand that?
Yeah.
Any example which you can, or should I do some example?
Yes, please. Yeah.
Let's see. The same example. We had a log of 100. What was the log of 100? You just told me.
Uh, 2.
Yeah. And can we write log of 100 also as 100 raised to the power of 2? 10 raised to the power of 2, sorry.
10. Yeah, we can.
Yeah. And now compare it with the third law. So it becomes, here the b becomes 10 and n becomes
N becomes the times of the.
no, here, if you
Oh.
compare with the above third equation, this solution, this question. So what is n comparing it with the third? So I'm saying you compare this with the this one.
Oh, N is 2. Okay.
Yeah,
Yeah.
n is 2. Good. And therefore we will say 2 log of 10. What is log of 10 to the base 10?
1.
So it becomes 2 times 1 is equal to 2. That's another way of. So it means these are good. Yeah.
Yeah.
Can you just with the same the question? So I'm just asking you. Okay, I don't do like this. I just put. So you have to tell me what if it is log of a to the base a. So what is the answer? Oh, sorry, I just wrote it actually.
Log of A to the base A.
Yeah.
I'm not sure.
Why? What
Oh,
were
is it
the?
equal to 1? Equal. It's
Yeah,
1. Yeah.
yeah. Look at the formula which I asked you to write it.
Yeah.
Okay, let me ask you one more thing. What is log of 1 to the base a?
I'm not sure.
Do you have the first formula? The one I
Yeah.
asked you to write.
Yeah.
So what it says, what should be here? That we raise that a raised to the power of this number, it should be equal to,
Um.
let me write it again so that you don't have a problem. We said log of, let me write the same expression, otherwise it would be a problem. So log b to the base a is equal to x. This means, what does it mean? A raised to the power x is equal to b. Yeah, that is the
Yeah.
thing which I asked you. So now what should be x here, that a raised to the power of that thing in the in the above question. I'm
Oh.
saying this, that become 1.
0.
Very nice, very nice. So it is 0. Got it?
Yeah.
Okay. Now we come to another, and uh, you can do like this as a rule, otherwise it's not a rule even. Oh,
Mm.
not a rule, I would say. Let's say, let me ask you. So third, it is a corollary of third rule. So what would be log of 1 over b equal to the base a? Let's look at the above. We are looking at the third formula. Have you written the third formula in your notebook?
Yeah.
Okay. So we have to find this, yeah? We
Mm-hmm.
would we can do like this also. Log of a b raised to the power of minus 1. Does it make sense to you?
Yeah.
Okay. Once it is like this, can you tell me what would be this from the third
It would
formula?
be
Minus log of
minus log, yeah,
b
a,
to the
yeah,
base a. We say
yep.
b to the base a. Yeah.
Beats, yeah, yeah. Okay.
We normally say the base afterwards. Yeah.
Yeah.
I don't know why this rainbow thing is showing here. Let me see. It's not going away. No. Okay. Yeah. So it means log of 1 over b to the base a is actually equal to log minus log of b. So you understand? This is also
Yeah.
something very interesting. Taking an inverse is like in the logarithmic scale, you apply the logarithm with the negative one. Yeah, good.
Yeah.
Okay. Let me now put one question and we do that. First, so you should have these your calculation notebook, and let's have the first question, please. It's a ATAR question, um, and it has 3 marks.
Yeah.
Question 1. Uh, write as a single, write as a write as a single logarithmic term the following expression. The expression is 3 log of x minus 2 log of y plus log of x square. This had 3 marks. So the question had actually 3 marks. So you have to write. So if you see here, these are 3 terms. You have to write it in one term. Just think about it.
Okay. I think I know.
You know, that's good.
Maybe.
That's good. That's good. You just write it in your notebook and then let me know.
And when I'm writing it as a single term,
Yeah,
can the numbers be on the outside? Should
it
the numbers be on the outside
it
or
can be outside. It's your choice.
okay?
So it should be a single log instead of these 3 terms. Log something. There can be a
Yeah.
number outside or
Yeah. So is it 12 log?
let me write it and we then
Yeah.
see. Yeah, do you say 12?
12 log
Let me write
bracket
in 12 log bracket.
x
Yeah,
times x over y in brackets.
x over y. So it becomes x square over y. Yeah, because they are
Yeah.
inside. Yeah.
Is it x squared over xy as well?
I don't know if it is x square over xy, then one x get cancelled with the one in the numerator. If you say like this, so this x get cancels with this. So you
Oh, okay.
so you have to give me the
So yeah,
answer which you have
I
found
think
after doing.
I think it's x squared over y. Yeah.
Yeah, let me dictate kindly tomorrow again. Kindly dictate.
So yeah, so 12 log bracket x squared over y.
Okay, let's look at it. Um, look at this equation, this, yeah.
Yeah.
Can I take this 3 inside the logarithm? So what would be this?
It would be x cubed
So with the log, so it becomes
or
log
log
x
x
cube.
cubed. Yeah.
What about the next? Minus
Log y squared.
log y square. Yeah,
Mm.
plus log x square. So far, so good.
Mm-hmm.
So I see that these two are similar. Sorry, I would just take this. So this and this is similar. Yeah.
Yeah.
So I bring them together. So this becomes log of x cube plus log of x square minus log of y square. So far, so good.
Yeah.
We had some formula. Can you say, can I write this thing in one?
Yes, you can.
What is that?
You can write it as log of x cubed times x squared.
Very nice.
So
X cube
yeah.
times x square. Yeah, minus log of y square. So far, so good. So this becomes now log of x to the power of 5 minus log of y square. Yeah.
Yeah.
And now look at the formula which you have written. Can I write it in some other form?
Yeah, you can write it as log x to the power 5 over uh y squared.
Very nice. So that's the answer.
Okay.
Yeah, you understood now? So
Yeah.
this is the answer. Okay, let's look at few more questions so that we are somewhat. Let me give you another question. So this is another question. Uh, just try to simplify it. Simplify, simplify. Yeah, this also has 3 marks. 2 log of 3 plus 1 over 2 log of 5 minus log of 4 to the power of minus 1. And naturally, it's all to the base 10.
Yeah.
Yeah,
Okay. I'll give it a try.
good. So we have again to simplify that it's a single log expression like the question we just did earlier.
Yeah.
Yeah. Are you doing good?
Yeah.
Okay, good.
I think I may have got it. Yeah.
Good. That's good. Yeah. So can you kindly let me know what is the answer?
So is it equal to log of 36 square root 5?
Yeah, that's good. That's good. That's good. Just going it quickly so it would be log of 3 square plus log of 5 raised to the power of under root 2, and that is plus log of 4. Yeah. So this
Mm.
3 raised to the power 2 becomes log of 9 plus log of 4 plus log of 5.
The fours to the power of -1.
No, we took that minus 1 down,
Oh yeah.
so it
Okay.
becomes
Yeah,
plus.
yeah.
So this becomes
Oh, okay.
plus, yeah, and
Yeah,
this
yeah.
becomes
Okay.
now log of 9 times 4 is 9 times 4 times under root 5. So this becomes log of 36, sorry, times 5. Yeah, so far
Yeah.
so good. Okay, just let me have few more questions quickly. Yeah, that's one more question. It is this has 2 marks, so you have to give simplify log of 16 to the base 4 divided by log of 64 to the base 4. So let me just ask you, what is log of 16 to the base 4?
Um, log of 16 to the base 4 is 2.
Good. And what is log of 64 to the base 4?
3.
Yeah, that's good. That's the answer.
Okay.
Okay, let's do also a question which is sorry, which is somewhat interesting, I would say. 2 plus log of 4 to the base 5 minus log of 20 to the base 5. Yeah,
Okay.
scale.
Yeah.
Then we looked at this thing, this formula, which says log b to the base a is equal to x, means a raised to the power x is equal to b. Yeah, we practiced few questions, very simple one. Then we went to the laws of algorithm. So the first law is, which is here. So let me highlight it. It says if two numbers are being multiplied and you are taking a logarithm, it is same as you take their individual algorithm and add them together. The second law was if you divide a number by another number, taking the logarithm of is same as you take the logarithm of first number and subtract the logarithm of second number. So I am talking about this formula. Yeah.
Yeah.
Okay. And then there was something, the third formula we learned, that if it is a power, it becomes times of the logarithm. So this is something which we did. And then another thing which we learned was this, that logarithm of 1 over b to the base a is like minus of log b. So it means, let me ask you quickly one question here. Can you
Mm.
say logarithm of 1 over 10 to the base 10 is equal to what?
You can say that is equal to negative log 10.
And negative log, what is log 10?
1.
1. So it is minus 1. Good. Then we did few questions where we tried to use these formulas which we learned of the logarithm. We did this one, some questions which were from previous ATAR exams. So I don't go into the details because we have been able to do it.